First, let's start with our inputs. Remember, Alex has a credit score of 80 and an income of 60, since we're using thousands. These two inputs get passed into the hidden layer. Each input connects to all 3 neurons in that hidden layer, giving us 6 total connections. Every connection has something called a weight attached to it. Think of a weight as a measure of importance. The higher the weight, the more influence that input has on the neuron's output. Here, we already predefined weights for our connections. Each neuron takes its inputs, multiplies them by their respective weights, and adds them up. We also tack on a little extra number called the bias. You can think of the bias like the neuron's built-in hunch or baseline opinion before it even looks at the data. In our case, a negative bias means the neuron leans towards not giving a loan, while a positive bias means it leans toward approving one. Finally, the neuron runs the total through an activation function. Activation functions add non-linearity, which basically means the model can handle messy, real-world patterns. Think of this like a filter. It decides whether the neuron signal should go through, and if so, how strong. In our case, we're using ReLU activation function. If a number is positive, we keep it. If it's negative, we drop it to 0. Simple, but super effective. Let's open up our hidden layer's first neuron, H1, and see what it's doing. Okay, so we can see our first weight of 0.3 in red. Our second weight connection is 0.5 and is in purple. Now we have to multiply each input by their own respective weight. We then add the results, and on top of that we have to add our bias. In our example, we have to multiply 60 by 0.3 and 80 by 0.5. We then add that up and then add our bias of 1. Now we apply the ReLU activation function. It's simple. If the number is positive, keep it. If it's negative, make it 0. 59 is positive, so H1's final output is 59. We repeat this for the other hidden neurons. H2 gives us 38, H3 gives us 44. Great, now our output neuron, the boss, has to make sense of these 3 opinions. It works the same way. Multiply each hidden neuron's output by its weight, add them up with a bias, and then run it through an activation function. That's a pretty big number, but we need to convert it into a clean yes or no. To do that, we use the Sigmoid function. It squashes any number into a value between 0 and 1. Basically a probability. A value of 56.9 gets squashed to almost 1, meaning the model predicts yes with near certainty.